So far, we talked about confidence interval for population proportion. Now we jump into confidence interval for population mean. So if I ask you to calculate or estimate the population mean, you're going to say that, well, you're going to take a random sample and then calculate the mean for that sample. Then we're going to say that, hey, that single value doesn't represent the actual population mean. So what's the meaning of that? It means that we need to form a confidence interval that captures the true value for population mean. So that's how we introduce the confidence interval concept. A point estimate is a single value that estimates population parameter. The most unbiased point estimate for population mean or mu is sample mean, which is denoted by x bar. Now, the interval estimate is an interval or range of values used to estimate a population parameter. It's not just one single value. We list the possible values, range of values that estimate the population mean. The level of confidence, as you remember, is the probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. Remember that C, or the confidence level, is basically the probability, is the area below the curve, and then critical values ZC and negative ZC are values that separate the sample statistics that are probable from the sample statistics that are improbable, or basically they are located in unusual part of the graph. And again, remember that we showed you how to use calculator to find the critical value for 90% level of confidence, 95% level of confidence, and 99% level of confidence. You either memorize these numbers or you use your calculator inverse norm to find these ZC or critical values. How do you find a point estimate? An econ researcher is collecting data about grocery store employees in a county. The data listed below represents a random sample of the number of hours worked by 40 employees from several grocery stores in the county. Question says, find the point estimate. So we have a population, a large population, and you took a random sample from that population. What are we going to do? We're going to find the sample mean, which is denoted by x bar, and it's going to be the best representative for population mean. So we add all of these numbers together, divided by 40, because you have 40 data in your collection, and it's about 29.6. So you're going to say that, hey, the point estimate for the mean number of hours worked by grocery store employees in this county is 29.6 hours. Well, this is not the true representative for population mean. So what's the meaning of that? It means that we need to find the confidence interval. Before finding the confidence interval, we need to find the margin of error, or E. Given a level of confidence like C, the margin of error, or E, sometimes called maximum error of estimate or error tolerance, is the greatest possible distance between the point estimate and the value of parameter it is estimating. For population mean, or mu, where sigma is known, the margin of error is E equals to ZC times the error, or critical value times sigma divided by square root of n. What is sigma? Sigma is the population standard deviation. Make sure the conditions are met. First of all, the sample is definitely random, and either the population is normally distributed or you have at least 30 values in your collection. So after calculating the margin of error, we can find the confidence interval. Well, let us practice a little bit. Let's use the data for the number of hours worked and construct 95% confidence interval. Before building the confidence interval, we're going to find the margin of error. Assume that the population standard deviation, or sigma, is 7.9 hours. Why it is important? Because our formula depends on sigma. Since you have 95% level of confidence, it means that the critical value, or ZC, is 1.96. The Z-score that corresponds to 95% confidence level is 1.96. This implies that 95% of the area under the standard normal curve falls within 1.96 standard deviation of the mean. Well, this is the visualization. 0.95 is 95% level of confidence. The critical values that are dividing the probable statistic from improbable or unusual ones are 1.96 and negative 1.96. Now, use the value ZC, 1.96, and sigma, which is population standard deviation, 7.9 hours, and which is 40, the number of data in our collection. We have 40 data in our collection. Margin of error is ZC times sigma divided by square root of n, which is 1.96 times 7.9 over square root of 40. This is about 2.4 hours. So what's the meaning of that? It means that we are 95% confident that the margin of error for the population mean is about 2.4 hours. That's the meaning of the margin of error. The maximum distance between population mean and sample mean is 2.4 hours. Now that we calculated the margin of error, we are interested in knowing how to calculate the confidence interval itself. In constructing a confidence interval, first verify that sigma is given to you. Sigma is population standard deviation. The sample is random, and either the population is normally distributed or n is more than or equals to 30. In the next step, you need to find the sample statistics, which are n and x bar. X bar, as you remember, is the sample mean, which is the summation of all values divided by n. Now, find the critical value ZC that corresponds to the given level of confidence. And then, calculate the margin of error E, which is ZC times sigma over square root of n. And finally, find the left endpoint and right endpoint. Your left endpoint is x bar minus E. Again, your x bar is your sample mean. E, the margin of error. And the right endpoint is x bar plus E. X bar is again your sample mean, and E is what you calculated here, the margin of error. Then the population mean, or mu, is bounded between x bar minus E and x bar plus E. So let's go back to that example that we started. Use the data to construct a 95% confidence interval for the mean number of hours worked by grocery store employees. We already calculated the mean. We already know that the population standard deviation is 7.9 hours. We have 40 data in our collection. The margin of error that we calculated is ZC times sigma over square root of n, or 1.96 times 7.9 over square root of 40. ZC is related to 95% level of confidence 1.96. And again, sigma, which is population standard deviation, is given to us as 7.9 divided by square root of 40, which is the number of value in your collection. And as we saw, it is about 2.4 hours. Now, what's the left endpoint? The left endpoint is x bar minus e. X bar is the value that we calculated by adding all of these numbers together and divide by 40. Remember, it was 29.6 minus the margin of error that you just calculated here, which is going to be 27.2 hours. And for right endpoint, you have x bar plus e, which is 29.6 plus 2.4, which is about 32 hours. So you can say that, hey, the population mean, which is mu, is bounded between these 2 hours. You can visualize it as well. The population mean or mu ranges between these two numbers, 27.2 hours and 32 hours. What is the interpretation? With 95% confidence, we can say that the population mean number of hours worked is in between 27.2 hours and 32 hours for sure.